Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello everyone. A very good evening to everyone present here. so, so those who are present in the session, can you please write your name in the chat box to confirm your presence, and therefore we can start very soon. I am sharing my screen as well. Also, confirmation that I am properly audible and visible. That would be really helpful. Okay, so my screen is shared. Okay, let me change the layout. Yeah. So I would request the students who have joined in this session to kindly write their name in the chat box. Hello Naikaj, how are you? Thanks a lot for joining today's session. Yeah, let us wait for a couple more minutes and then we can begin so that other people could join. And meanwhile, let me tell you that today I will be discussing about topics like height of a binary tree. Just a minute. Height, diameter, and the diameter of a binary tree. Then what do we have today? We got height. Then we will discuss about the concept of balanced binary tree as well. Apart from that, yes, that's it. And if we are able to find time, then we will discuss about lowest common ancestor as well. Otherwise, we will keep that for our next practice sessions. Okay, so this is it for today. So let's see how many have arrived. We have 4 people with me right now. Okay, Nikach, everything is fine, then that's great. Okay, so let me give you all an introduction about the session. This is the tree series, which is going live on GFG practice channel. Okay, so I would request everyone to kindly like the streaming as well as subscribe to the GFG practice channel so that you do not miss any content that we will be having. And today is the second session. And in the previous session, we discussed about representation of binary tree and about its various traversal. We discussed primarily about the BFS and the DFS part. In DFS, we learned about in order, pre-order, and post-order traversal. We saw the recursive formulation. In the next week's session, we will be seeing about iterative implementation as well. Okay, and for BFS we have level order traversal. Okay, so this was it. Today is the second session, and we will be discussing about um, then diameter, and the concept of balanced binary tree. Okay, so we'll be discussing these topics today. Okay, and you will find the link of this Google Jamboard session in the description of this chat. You can check that out. Okay, so yeah. Let me give you a small introduction about myself. My name is Gourav Kumar Shaw, and I'm presently in my third year at IIT Kharagpur. And I'm a mentor at Geeks4Geeks and bringing to you this craft series on GFG YouTube channel. Okay, so um, how about you all write your in which year are you all right now in your college? Are you preparing for your upcoming internships and placements interviews? You can write that in the chat box. And I would request everyone to kindly be interactive during the session, which would be very, very helpful for us. And it would also motivate me to deliver great content to you all. Okay, so let's start then. Okay, so first thing that we will know about is the depth of a binary tree, and in fact, we also call it a height of a binary tree. Okay, so what exactly is height and what exactly is the depth? Let us see the first. So basically, can you all can see this tree, right? Now the question here is that what is the height of this tree? Okay, so you see that at height one we have level number one. We see node one is present. At this is the level number two. This is the level number three, and this is level number four. So in total, we see that the height is equal to 4. Okay. So how do we? What is the concept behind, and how can we get the height of a given tree? Let's say you are given only the root of a tree. Okay, you are not given anything else, And you know that every node of a tree contains a left pointer and right pointer. So you, from these information, your task is to find the height of a tree. So what approach will you utilize? So how will you implement so that you get the height of a tree? In this example, the height is equal to 4. Naika is asking, can I get a job in MNC in second year of my BCA? I'm not very sure exactly about this. I think you can get a job only after your graduation, full-time job offer for that purpose. So if BCA, I guess, is a 3-year course, so in that case you have to complete your course. But you can do apply internships uh, through referrals or through off-campus portals. That would be helpful. Okay. So we have 9 people with me right now. I would request everyone to kindly stay with me till the very end and also like the session. Another important announcement is that from the this Friday we will be starting a dynamic programming series as well. So that will be very interesting, and it will be based upon all the practice problems. Practice. It is a question-oriented series, so it will be very very helpful for your interview preparations. Okay, and also meanwhile you can check the the Geeks for Geeks self-paced course link that is present in the description. Okay, so that is one of the very very great well-crafted course which can any beginner can take to start their learning in data structures and algorithms. Okay, okay, Naika is saying it's a simple DFS problem. Okay, that's very well, but yeah, the simple DFS problem, the concept would require recursion. Can you tell the time complexity in that case? What will be the time complexity? Samant is asking how is placement going on in your college? Are you asking my college or are you asking the audience in the chat box? Okay. O of H. Okay. Can you tell me, Sumit, that in worst case scenario, let's say I am giving you a skew tree in which all the nodes are lined one by one after the other. In that case, do you think recursion would be helpful? A DFS kind of approach would be helpful? Okay, Shamnath. So basically, yeah, like, placements are good, but definitely not like the previous year because of the hiring freezes that are going on in the tech domain. But other domains, the placements were kind of good, except software. So yes, yes, because of recession, many companies which were supposed to come did not come this year. So we are hopeful they would be coming next year. Okay, so it is n square, yeah. So if you apply your DFS type of um, approach, in that case you will get a TLE because it's an O of n square. So how will you optimize that approach? Any other ideas, Naikaj? The concept is already written on the slide. We can do O of n using DFS. Yes, we can do. So, but you can do that, but you have to make some kind of observation before you proceed in that direction. Can you tell me what observation is that? And in fact, what you can do basically, you can also do iteratively as well by doing a level order traversal. In that case, also it is possible to do in O of n. Okay. Okay. So, yeah, we need to store the max height at the current and every level. So let's say I have already written up a formula here, which is equal to 1 plus max of left and right subtree. So let's say you're standing on the root that is equal to 1. So what you will do, you will find the height of the left subtree and the height of the right subtree. recursively there, and we will add 1 to the whatever maximum it will come. Okay, so whenever I am calling for the root, it will call for the left and the right. After that, 2 when it comes to node number 2, it sees that the height of the left subtree is 0 and the height of the right subtree is also 0. So in that case, what will happen? The node number 2, it will return a value of 1. Okay, so it will return a value 1 to the node number 1. Now 3 will call 4 and 8. 8 will return 1 because 8 doesn't have anything else. 4 will go to 5. 5 will return 1. 2, 1. Now 4 will basically become 2 now. Okay, because 1 plus the left part is equal to 2. Now 2 plus 1, 3. 3 plus 1, this will be equal to 4 now. Now this 2, the maximum of left and right is equal to 2, and 2 plus 1, sorry, this will be 3. Okay, so just a minute. Yeah, so this will be 3. Okay, now 1 and 3. So the maximum is 3. Now 3 plus 1, this will be equal to 4. Okay, so what we are doing, we are recursively calling for the left and the right part. Okay, so we are recursively calling for the left and the right subtree. And what we are asking for the height of the subtree. And then what we are doing, we are taking the maximum of both the heights. And we are adding 1 because that particular node is also a part of a new height. So in that case, we will be able to solve this. Okay. So let us just implement this exact same concept in GSG portal itself. Okay, so you all can Google. Okay, so height of a binary tree. This is okay. So in the question, you are given a binary tree and you have to find its height. Okay, so or in fact, what we can do. Yeah, in worst case it can be O of n because tree can be yeah, skewed. Yeah, that is correct actually. So let us look into this question, maximum depth of a binary tree. So what will happen here? Yeah, so I have already implemented this concept. What we are doing, we are recursively calling for the function max depth, and we are calling for the left part, then the right part. Okay, now what we are doing, we are returning 1 plus the maximum of LH plus RH, and in that case whatever it will return will be our answer. And also if the root is equal to null, we are returning 0. So finally whatever the caller function will get will be our answer. So let me submit this code and check whether it is correct or not. Yeah, so as you can see, all the test cases have passed, so therefore it is correct. Okay, now one more thing I would request you all kindly to make a note of. Okay, so one of LR left subtree and the right subtree is very important because this concept will help us find the solve the other questions as well when we will look into the other part, that is finding balanced binary tree and not. Okay, so let's proceed to the next part of our question. Okay, so let's see. Yeah, now what do we have next? Meanwhile, do you know we can actually solve this iteratively as well? Can anyone tell me an idea? How can we solve this iteratively? Nikaz, Sumit, how can we solve this iteratively? In that case, also it will be O of n. Okay. Yes, it is same as the height of a binary tree as well. Yeah. So one more thing is that I told you all that let me give you a hint for the iterative version. I told you that height of a or the maximum depth of a binary tree will be equal to the number of levels in that tree. Okay, so what you can do basically, you can think of a level order traversal kind of concept. And what will happen when you think of a level order traversal, you count the number of levels it is getting processed inside the queue. So that will be your answer in that case. Okay, so let me show you how. So what you just do basically, you declare a queue, you add the root to the queue, then you initialize a variable called int level equal to 0. After that, what you do, you basically Yeah, you basically go to the left part and the right part, and subsequently check for all the levels. Okay, and the number of levels it is getting processed will be equal to your q. Okay, will be equal to your maximum depth of a binary tree. Yeah, we need to store the level at every point. Yeah, so that will be one of the approach for iterative version, and it's always better to know the recursive as well as the iterative version because it will help you in your interviews. Okay, so let's move to the next part. Hmm. So the next concept that we are supposed to discuss today is about balanced binary tree. So anyone know the definition of balanced binary tree? Can you please write a small brief description about it in the chat box? Hmm. Yeah. So basically, the concept of balanced binary tree. Yeah, so the concept of balanced binary tree is something like this. The absolute value of the difference of height of the left subtree and the right subtree should be at max 1. Okay, so what is this exactly? Let me tell you in detail. So let's say you are standing, you are given a tree and you are standing at any particular node. So you calculate the height of the left subtree, you calculate the height of the right subtree, and the absolute difference between the height should be less than or equal to 1. It means that it should be either equal to 1 or it should be either equal to 0. It means that the height of both the subtrees should be either same or one of the subtrees should be just one node greater than the other. In that case, we'll call it a balanced binary tree. Let me give you a few examples and you will tell me whether it is balanced or not. Okay. For example, if this is a tree, this is one node and this is another node. Okay. And this is okay. So tell me, this is tree number one and this is tree number two. Whether it is balanced or not. Any ideas, anyone? Is number one balanced or number two is balanced? Which one of them is balanced? Okay, now the condition which I just told is that the absolute difference of the height of the left subtree and the right subtree should be less than equal to 1. This should be valid for each and every node of the binary tree. Okay, both are balanced. Are you sure? Vishal is saying 2 is balanced. Okay, the first is balanced. Yes, the first is balanced, and is second balanced? Yeah, the first is balanced, but the second is not balanced. Okay, so let's see how I meant. See, for let's consider this way. So for tree number one, in the root node, we see the left subtree has a height of equal to 1 and the right has a height of equal to 2. So the difference is equal to 1. So it is balanced for this node. For this node, the left is equal to 0, right is equal to 0. So in fact, the absolute difference is 0. Therefore, still balanced. For this node, left is equal to 1 and right is equal to 0. So therefore, again balanced. For this node, both are equal to 0. Okay. So again it is balanced. After that, yeah. So after that, what we will do here is that let's say for this node we are considering, in that case, for set tree number 2, the right subtree has a height of 3 and the left subtree has a height of 2. So it is balanced. But let's talk about this. In this node, what will happen? The right subtree has a height of 2 and the left subtree has a height of 0. Okay. So what is happening here? The difference becomes 2. Okay. Since the difference becomes 2, in that case we can say it is not balanced. Okay. First is also not balanced. How? I think first is balanced. See, for this node, the height on the right is equal to 1 and left is equal to 2. Okay, so height of left minus right, 2 minus 1 is 1. 1 is less than equal to 1. For this node, it is 1 and 0. So again, it is 1. For this node, it is 0. Okay, so in that case, we see that the first is balanced. Yeah, so yeah, I guess this may get confusing. Just see, what you can do here is that you go across each and every node, try to calculate the height of the right and the left. Take the difference, absolute difference, and see whether it is greater than less than equal to 1 or not. If it is, if it is true for all the nodes of the tree is balanced. Okay. Okay, so the tree is balanced in that case. So Sumit, no worries, Sumit. So Sumit, can you tell me any ideas that will help you solve this problem? How am I supposed to implement this within an optimized version of an implementation that will help pass the TLE as well? Any ideas? We will get the height of both subtree and compare. Okay, how to calculate height of the tree? Vishal, we just discussed it just a few minutes back. Okay, so let me just revise it for Vishal. So you can check up the slides. So all you have to do is basically take the maximum value of the left and right subtree, add 1 to it at every node, okay, and take the value for the root node. This is how a recursive code will work. Okay, so but right now we are discussing about how to find if it is a balanced binary tree or not. Okay, so let's see. Naika is saying we need to set pair at first. We can store the height, and the second we need to store bool value true or false. So time will be O of n. Okay, Sumit is saying we will get the height of both subtree and compare. Okay, so height of both subtree. So let's say at O of n approach we were getting the height of both the subtrees, and then let's say if you're running this comparison for all of the trees again, so the complexity of what Sumit you are saying is the complexity will become big O of n square. Okay, so any other ideas that you can actually take? Okay, so basically comparing for every node, 'cause you are asking that you will calculate the height at every node, you will compare and you will see. So calculating height takes O of n. Comparison for every node will again take O of n. So total will be O of n square complexity. Okay, so just you try to utilize the idea that height of a left subtree minus the height of a right subtree should be less than equal to 1. Okay, so just this idea. Okay, so Sumit, what you are saying, I have already written here. So let's say basically, okay, so let's say that. Okay, so let's say that you have a bool check. So you pass the node, you find the left height and find the right height. Okay, by finding the by find height function. After that, you compare the height and then return false. And again, you call the check function for the left and the right part. Okay, and if both the left or both the right are not true, in that case, return false. It should be true for both the cases, right? And finally, if it is, in that case, you return true. But this recursive implementation is taking O of n, this recursive implementation is again taking O of n. So therefore we are getting O of n square. So we don't want O of n square, we want O of n. Yeah, Naikaj, I got your idea. Yeah, we will be doing that, but instead of taking pair, since we are going through recursion, so why not just return the value at that point only instead of just storing it in an extra set? Okay, So the next approach would follow something like this. Let's have a look at it. So what we are doing, this was a function for getting the height of a binary tree. Okay. So what we were doing, we were passing the node, and then we were checking whether the node is equal to null or not. If it was, we returned 0. After that, what we did, we were calculating the left part and the right part. So just after we calculated the left part and the right part, let's just put a check. Okay. So what we will do basically is that we will just put a check. Okay, that whether the absolute value of the left and the right are equal to less than equal to 1 or not. Okay, so what will I do here? Okay. So if it is greater than 1, I will just return -1 in that case. Okay, and if it is not greater than 1, I will just return the height of the tree. Okay, so did you get the idea? Yeah, we can use a pair of height, but let's see an implementation which is without taking any pair of height. Okay, so let me just give you a link of balanced binary tree. Okay, so hmm, I hope everyone can see the screen. So if you will just if you will just use this function, the function which I'm just showing it to you. Okay, okay. You want me to share the link of the question? Okay, so let me paste the link on the chat box here. Yeah. So I have pasted the link in the chat box. As you can see in this function, what exactly is this function here? Okay, so in this function we have something called the DFS height function. So this is very similar, or in fact exactly similar to the code that we use to calculate the height, the maximum of the left subtree and the right subtree plus one. Okay, but in this case we have to find whether it is balanced binary tree or not. So what we'll do basically here is that let's say if it is a balanced binary tree, I will just return the height. But if at any point of time I see that it is failing the validation check for balanced binary tree, that is the absolute value of the left and the right height is not less than equal to 1. In fact, it is greater than 1. So I will just return -1 at that point. And if at any point of time I'm returning -1, I can just say that it is not a balanced binary tree. Okay, so this will be the check part of the function. Okay, and apart from that, what will I do? One more thing that is left is this was a caller function. Okay, so in this case I will just write return. I will see that send the root to this dfs side function. If it is not equal to -1, I will just return true, and if it is equal to -1, it will return false in this case. So this is the concept. So yeah, so we go to the left height, and if the left height is again -1, in that case also we will return -1. Okay, because if left height is -1, it is not a balanced binary tree. This condition is also need to be mentioned. If right height is -1, this condition should also be mentioned. Okay, we can just return -1. Okay, and if not, if the high absolute value of right and left are greater than 1, we will return -1. If all these three return statements are not getting executed, it means that particular node is actually the balanced node. So in that case, I will return the height, the actual height. Okay, because this is a positive number. Okay, so it will treat any other number which is not as -1 as a true condition, and the number -1 will be treated as a false condition. Okay, so this is the concept regarding the balanced binary tree. The time complexity of this is linear time complexity O of n, and in fact the space complexity is basically big O of h, because we are using the recursion, and recursion will take a stack space. Okay, and Nyquist, the concept you are telling you involves us taking extra space. Okay, so in that case, okay, so this should be just node star, I suppose. Yeah, let's submit that. Okay, so as you can see, all the test cases are passing. So therefore, this question is correct. Okay, so this is regarding the balanced binary tree. So let's proceed forward then. Any doubts till here? Okay, Nikaj, you were saying that it does not take in. You're talking about pair C++. Yes, I'm getting it. Yeah, can you just write a small pseudocode in the comment section? That would be helpful for me. Okay, so in fact, does your like I'm see. Uh, Basically, what I understood from your statement is that you are trying to store whether every node is balanced or not in the form of a vector of pair, right? So if you are storing that, and after that you are checking that whether all that are true or not. So in that case, I was assuming that it should be a vector of pair in that case. So for if there are n nodes, so you should have to declare a vector of size n, which will contain the a pair, which will contain the node number and whether it is balanced or not. This is what I understood. If you meant anything else, you can just please describe it. In that case, I will understood it much better way. Okay, so yeah. Meanwhile, Naika is writing. I would request everyone so who are watching the stream to kindly like the session, as well as okay. I got it. So basically, you are using a recursion, and in recursion, see, in my code, what I did here, uh, I just returned -1 if the condition for this was failing. So what do you intend to return in that case? So you are saying is that we will use pair of height and a boolean flag. We need to set pair at first. We can store the height, and at second we store a bool value true or false. At two, time will be O of n. Okay. Well, if it's possible, can you please write a small pseudocode implementation so that I can understand? Yeah, well, Naikaj, what you can do, you can try to submit a code on the GFG practice portal itself, and if it's AC, just copy that code in the chat box. Okay, that would be helpful so that other people can also see your approach. Okay, in case if it is something very interesting, then it will be helpful for everyone. Okay, so meanwhile, let us continue. Yeah. So the next part that we were supposed to discuss was diameter of a binary tree. Okay. So okay. So diameter of a binary tree. So let's see how does the diameter of a binary tree works. So in this case, it's the longest path. So the definition of diameter it is that it is the longest path between any two nodes and does not need to and it does not need to pass through the root. Okay, so what does this mean? Let's say if I say that this is the longest path between any two nodes, this is one node and this is one node, and the path between any two nodes is covering 1, 2, 3, 4 nodes. So I can say this is the diameter of the tree. Okay, and it does not need to pass through the root. Okay, so what does this mean? That it is not necessary that the path should pass through the root. For example, if I am considering that it should pass through the root, in that case what I'm saying, this is the path. So the length of this path is 1, 2, 3, 4, 5, and 6. But this is one of the path which is of a much longer length, and the length is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so length is equal to 8. So in that case, what I mean here is that this is the diameter of this tree is equal to 8. Okay, so I hope you all understood that. Okay, so how to find a diameter of a tree? There are many other methods that we can try to use to find the diameter of a tree. But in fact, what I would like you all to do right now is try to modify the code of the height of when we were trying to find the height of a tree by taking the maximum of the left and the right subtree and adding 1. So use that concept to find the diameter of the tree. Okay, so if you get it, then kindly tell me. You were Sumit is saying math.max result or height of right plus. Okay, is it necessary that we should add 1, or if it just say if you do not add 1, will the answer be wrong? Okay, so what I was saying here is that, yeah. So what will be the time complexity of this approach, Sumit? If you are calculating the left and the right height, just a minute, you said height of the left plus height of the right plus 1. Okay. Okay, so basically you are calculating the height of the left and right at every point of time, and you are returning the maximum value of the addition. Okay, so in that case, the time complexity should get quadratic, right? Because both are taking, and for every node, height function is called, which takes O of n time. Hence, every node it becomes n square. So see, exactly the similar kind of optimization that is needed when we were trying to find whether it was balanced or not. O of n. Okay, so actually this will become O of n if we just take a extra variable. Okay, so I've already mentioned here. Okay, so basically what I was trying to say here is that, let's say what you do, you try to find the sum of the left height and the right height. Okay, and you do that for every node. So this is the brute force idea, and it will become O of n square, but you can optimize it. Sumit, did you mean this concept what I just described, that you are trying to find the left and the height of the left subtree and the right subtree for every node? Okay, so so if you're trying to find that for every node the time complexity will be n, and you're calling the height function. So again, the time complexity will be n. So total will be big of n square. Okay, so but a very simple, just a small change can help you write the optimized version as well. So I will just tell you how. Let me share the question then. You can store max height and current height for every node. Same question. Yes, exactly, Sumit. You have to use a variable that will actually help you store the and return the max height of the subtree. Yes, exactly, Sumit. So if you are actually taking a global variable, in that case, it will be helpful from getting from n square to O of n. Okay. So just let's have a look here. So what you can do here is that you can declare a variable called, let's say, diameter inside this function. Okay, inside this function you declare a variable called diameter, and you again create a function, okay, that will be equal to height, okay, and you pass the root and the variable diameter in that function, okay, and that will basically what it will do, at every point of time it will calculate the maximum of two values, the diameter already present and the sum of the right part and the left part, okay. So this the what will happen, the maximum of all the sum of left subtree and the right subtree will get stored in the diameter variable, but this function is just doing exactly what it should do, that is find the height. It will return 1 plus max of LH plus RH. So what will happen, in O of time complexity, only after the entire height function gets done, the work gets done, we will have the value stored in the variable diameter, okay. So in that case this will be the process, okay. Yeah, you can do. Okay, I got it, Naikaj. What you were trying to say is that instead of, you can keep a pair and then you can yeah, keep a and then pass that pair and then try to check. Got it, Naikaj. Okay, so this is how it should work. So let me submit this problem and check. There is a small compilation error. Let's see what it is. Okay, so this should not be tree node. It is declared as just a node. Let's see then. Yeah, so one small error is that we have to basically put 1 plus left plus right, okay, because that is how the definition of diameter it is, okay. So 1 plus the height of the left subtree and the height of the right subtree both will sum up to get the answer. Okay, so this was about the height of the binary tree. Any doubts here? Since we have a some amount of time left, we can discuss about lowest common ancestor as well. So any doubts here? So, Sumit, Naikaj, any doubt? Yeah, we have 7 people with me right now. And in case if anyone have joined the stream late, I would request everyone to kindly subscribe to the channel and like this session. Apart from that, yeah, because we are planning to release a lot of great content that will help you in your interview preparation as well. So from Friday onwards, you will basically see a dynamic programming series. It is also being brought by one of my colleagues at Geeks for Geeks, and I hope along with graph and trees and dynamic programming series, in fact, we will be launching further practice series again in the month of February and March and so on. So this will be helpful. Okay. Yeah, basically, I did not meant a global variable, Naikaj. You see, I declared a variable called diameter inside my function, and then I just sent the variable diameter as a reference, passed by reference to the height function. Okay, I did not declare anything globally. Okay, so yeah, that's yeah. It is always not a good idea to declare global variable because you may lose track of the values it is getting assigned with. Yeah, this is correct. So let us move back to our discussion with lowest common ancestors. So does anyone have any idea what are lowest common ancestor? So do you know that finding the height, do product based company ask the same question that are in the GFG practice session? Like there are no correlation between these two topics. GFG practice session section will help you practice all the concepts of data structuring algorithm, which will be helpful for your preparation for product based companies. Okay. So there are other resources as well. You can use lead code as well, lead code, and apart from that, there are interview bit as well. So you can there are plethora of yeah, topics which you can basically see. Then in fact there is a very extremely good structure maintained by Striver A to Z sheet. You can refer that. I have personally, before my interviews, I actually went through the Striver's A to Z sheet. At that time, it was the SDE sheet just a few months back. So that was kind of very, very helpful to me. Okay. So, okay. So let's look into lowest common ancestor. So can anyone tell me the definition of a lowest common ancestor? Anyone can tell me the definition of lowest common ancestor? Sumit, Naikaj, anyone? The lowest common parent of the two nodes, exactly. So, yeah. So let's say the question would be something like this. You are given two nodes, okay, and you are given the root of the tree. Now it is being asked to find the lowest common ancestor of the tree. How will you do that? Okay, so let me just write lowest common ancestor, CFD practice. Okay, so lowest common ancestor in a binary tree. Okay, so let's see this. How will you do it? You are given two nodes. The first is equal to unique values and two nodes n1 and n2 to find the value. Okay, so you are given a two nodes and you have to find the value. Okay, and the question it is mentioned that all the with all unique values, the all the nodes have a unique value. You are given a root as well. So what exactly is the idea? So the idea is something like this. What we can do here, let's say we can do a recursive call for the left and the right subtree. Okay, and if the left subtree recursive call gives a null value, that means that we haven't found LCA in the left subtree, which means we found LCA in the right subtree. So we'll return right. Okay, so if both are giving null, it means that the root is the LCA. Okay, so how it is the LCA? We can Sumit is saying that we can find any value in left and the other in and then other in right, then we make the result as variable is equal to current equal to variable. Okay, first I have to store the path to the root to the left and root to the right and then check when both the nodes match or not. But in fact, Naikaj, what will happen, you are taking extra space here. Okay, you are storing the entire tree in any vector and then you are basically trying to vector. So this is also a nice approach to solve this problem, but any other approach in which you are not taking any extra space. Okay, so in the question you see the expected time complexity, yeah, height of a tree. Yeah, so the question is basically saying the height of a tree will be the expected auxiliary space is the height of the tree. So yes, Naika, you can actually take that. You can take that approach, but it is always better to when you are in an interview, always say the interviewer will ask you that can you just do that without using the extra space. So how will you do that? The question would be something like that. So that is the concept. So I'm pasting the link of this question in the chat box. Okay. In fact, this is not a very difficult problem. Yeah, you can use the concept of height of a tree. In fact, using the concept of height of a tree, using the concept of left and right subtree will actually help you solve this. Okay. So, so yeah. So what I would like to say here is that let's keep this as a homework. Lowest common ancestors. You can just try to solve this question by your own. In the next session, which will be a practice session, we will basically do problem which will involve the application of lowest common ancestors. Okay. So this is just a standard problem. So which you can do it by yourself. And I will also put a link that will help you to understand. There will be GFG link as well on the article section, so you can get an idea about that. Okay, so what I want you all to do is do it in both the ways. What you can do, you are standing on given node, let's say the node number n1. You try to go back to root. Okay, and you try to store all the nodes from n1 to the root. Again you go from n2 and you again go back, and then you see the first point basically that will help you, the common point. Okay, so that will be your lowest common ancestor. Okay, so in that case you can get that, but apart from that you can also use the concept of subtree as well, so that will also be helpful. So what you can do in subtree, what happens is that you go to the left subtree and then you go to the right subtree. If left is equal to null, in fact you start from the root, and if left is equal to null, you return right, and right is equal to null, you return left. And if both the left and the right are equal to not null, so what will happen, you will just return root. Okay, and if it is equal to p, or the root is equal to q, you will just return the root part. Get it? So that this is how and the complexity of this code is bigger often. Okay, so I'm pasting a link that will help you basically to solve this question. You can just save the link in language. Okay, so in the next session we will be having practice problem graphs, related to trees, which will be basically application based of lowest common ancestors. Okay, so this is from my side for today, and if you have any doubts you can ask in the chat box. I am here for a couple more minutes and then we can bid goodbye. Okay then, yeah, I would request you to kindly watch the dynamic programming session from Friday onwards, which will be very helpful, and see you next week then with practice problems. Okay, so I wish you all the best for your preparations, and also I hope that everyone have a great year in 2023. Okay, so bye bye, good night.